All right, so first of all, I just wanted to point out, somebody asked about this, um, that on this little table that I have, we're looking at chapter 3 questions. That's going to be the questions in this row right here for vectors and projectile motion. And notice that these questions are from exams 1, and then the green is from exams 2. So just make sure we're clear on what the color means, the exam, and the row is for the chapter. So if you have any questions about that, let me know just sort of how I do that. Don't forget to seminar today at 4. So if you want to stay after, we'll probably finish up here in about 30, 35 minutes. But then you can come see Dr. Abear at 4. All right. Particular questions, either from exam 1 or 2. I didn't get any on email, but if y'all have particular questions, I can address them now. Yeah, Lillian? Fall 2021. Okay. Just want to remind you, though, no free response on the quiz, but you will have a question like this, okay? So it's not a bad idea to be practicing just while you're practicing for the quiz. First of all, the mass is not important. You don't need the mass. I have ground level, starts, ends at ground level. I like to draw a picture. This helps me to think about it. This angle right here is 60 degrees. I like to go ahead and calculate my V naught X and my V naught Y. I know that I'm going to need both of those. I just get them, at the tips of my fingers. So just do that first thing. V naught X is 22 cosine 60. That's equal to 11. And 22 sine of 60 is equal to 19. All right, so those are those components of the vector. This is 19 meters per second, and this is 11 meters per second. The components of the initial velocity vector. First thing I want to know is what is the maximum height of the ball? What is the maximum horizontal range of the ball? How long does it take to come back to ground level? And then what is the speed? So we're going to need the time. So really we're answering part C first. That is, what is the time? So let's just, I need to know the time. I know that up here that the velocity in the y direction is 0. Not the velocity in the x direction, just in the y direction. It goes up, stops, and comes back down, but it continues to have that x motion. Okay, so I can say that Vy at the top is equal to 0, which is equal to V naught y, that's 19, plus negative 10 times T top. So T top is equal to 1.9 seconds. That's 19 divided by 10. Let me fix this. 1.9 seconds here. That means right here, twice that, or 3.8 seconds. That's the answer to part C, by the way. The total time is 3.8 seconds. But I need that also to find the height of the ball, the maximum height of the ball. So part A is what is the height of the ball? That is that y is equal to V naught y t plus 1/2 ay t squared. But now that I have the time, I'm just plugging that time at the maximum height to get that y position at that time. And I know the time at that position is 1.9 seconds. So I get V naught y, which is 19, times 1.9 minus 5. That's just half of negative 10 times 1.9 squared. That's 18 meters. All right, so that means that that distance right there is 18. The maximum horizontal range, x is equal to Vx times t. Vx I already have, that's 11 meters per second. Now I need to know the time. I'm taking the time at the end of the trajectory right here. So that's going to be times 3.8 seconds. 11 times 3.8 is 42 meters. C I've already answered. And then D is what is the speed of the ball? C was 3.8. D is what is the speed of the ball at t equal 3 seconds. Look, that's going to be right about here, right before, after it passes over the top and before it reaches the end. And recognize that it has two components. One component is 11 meters per second. That's this value. The other component is the velocity in the y direction. So I need to determine what is that velocity in the y direction. Velocity in the y direction at that time is v naught y. That's 19 meters per second. I got that from up here. Plus ay, negative 10, times the time, which was 3 seconds. That's given in that part of the problem. And so the velocity is 19 minus 30, or negative 11 meters per second. Oh, yeah, so that's the same as the x component. So I have a vector 11 in this direction, a vector negative 11 in this direction. I want to know this vector. So say the square root of 11 squared plus 11 squared. Just drop the negative because it's squared. And that gives me 16 meters per second. That's the speed of that object at 3 seconds. So it's fascinating. But every single one of those parts, there are similar multiple choice problems to each one of those parts. I like to ask those kinds of questions. What do you think? I'm sorry. Absolutely. So she asks, what formula to find time and what formula to find V? D. Yeah. So to find the time, that's this part right here, where I'm finding T top. I'm saying that V is equal to V naught plus A times T, right? It's one of those kinematics equations. Except I have my Y subscripts here because it's only in the Y direction. But then, remember, like in chapter 2, we said that if this is at the top of the trajectory, then it's equal to 0. So I say 0 then is equal to V naught Y plus AY times T. And now that's going to be T top. Just like we did in chapter 2. That's a really important step because usually that's going to be the way that you find the time for that object as it travels through its trajectory. That you're going to use the fact that the velocity at the top is equal to 0. And so you have some information about that point in space, allows you to determine the time that it's in the air. And then this other one down here for part D, I wanted to know the velocity in the y direction at a particular time. Now this time right here was given. So there are 3 times floating around in this problem. I have the time at the top, that's 1.9 seconds. The time at the end, that's 3.8 seconds. And then this time that's given right here, which is just 3 seconds. I know the velocity in the x direction at that point because it doesn't change. It's 11 meters per second. But I also have to find this velocity because that object is going downward with a certain velocity. In order to find that velocity, then, well, I'm using the same equation. Vy is equal to V naught y plus AYT to find that velocity. Let me just write down the projectile motion equations too while I'm here. So in the x direction, we have 2, really just 1. I'm just going to write 1. X is equal to Vx times t. Remember, this is, well, let me write the y ones first next. And then for y, we had y equals V naught y times t plus 1/2 AY t squared. And then Vy is equal to V naught y plus AY t. So in the x direction, AX is equal to 0. In the y direction, AY is equal to negative 10. That's why these equations look so much simpler. They're exactly the same as these others, except I lose this term because AX is equal to 0, and I lose that term. So I don't even write that second equation because all it's saying really for the x direction is that Vx is equal to V naught x. That is that Vx doesn't change. X velocity is constant. the equations, but as y'all know, like knowing the equations, that's not the hard part. Y'all probably already know these equations because we've used them a lot over the past few weeks. But that's not the hard part. The hard part is applying them into that particular situation. Knowing equations isn't enough, as y'all, I think y'all know that. Okay, does that answer your question and more? A little bit. Okay. All right. Other particular questions? Yeah, William. Oh yeah, yeah. This number 9 comes up on exams. I don't know that we did one of these in class though. We might have done them in one of the sections, but it has come up past few years. So in this, I have two vectors, vector A and vector B. Notice I don't give their magnitudes, I just give their directions. And so I can sketch them out. Vector A is 10 degrees below the negative x-axis. So I'm going to draw vector A like this. And then vector B is 340 degrees from the plus x-axis. Let's see, where would that put it? It puts it in the fourth quadrant. It's going to be right over here, 340 degrees from there. So that's where vector B is. Vector B goes over here. Now the sum of those two vectors, A plus B, has to lie somewhere between these two vectors. If vector B is really, really small, then that means that the sum of those two vectors is going to be over here. If vector A is really, really small, that means the sum of those vectors is going to be somewhere over here. If they're the same, then that means that the vector sum is going to be right down the middle. But it has to lie between those two vectors. The sum of these two vectors cannot lie in this region. It has to be in between these two vectors. So that means that I can't have A or B or C. I could have D and I could have E. So it has to be answer D. Okay? And then number 10, which you'll definitely have on the exam, because that's on every exam that I've ever given, is how to do this graphical analysis. What is A minus B? So recognize that it is a negative. That means I'm going to be flipping the direction of the vector B. So I'm going to start with the vector A, right there, and then I'm going to draw the vector B, but the opposite direction. So it's going to look like that. And then the sum of those two vectors, I'll start at the beginning and draw to the end. The sum of those two vectors is going to be that vector, which is represented by arrow D. That's going to be question number 1, I'm pretty sure, on your quiz. And, you know, on the exam, too, you'll have a question like that, too. But definitely on the quiz, one of those. There's probably a dozen of those if you look back at past exams, or one on every exam. So take a look at those. There's variations of those. This one, I've given a number of these over the past several years. All right, other particular questions? Or I can just sort of scroll through. You know, if you look at the, yeah, go ahead. Okay, I like these too. What I was about to say is that as you look through the exams, you see that there are questions that are often repeated. Like the two with the two arrows, that's often repeated. Questions like this are often repeated. So that should give you some inclination as to what kinds of questions you're going to have. So, okay, they're always the same. They're not the same, but you know, they're often the same. Okay, the velocity of the ball at the top is 0. Is that statement true? Well, it's true that the y velocity is 0, but the x velocity is not. The x velocity is constant. So 1 is not true. And then, like I said in class, you know, go through and mark off the ones that you know can't be possible. Oh, sorry. Wait, no, that one. So it can't be this one, or that one. So it has to be either A or E. The horizontal component of the velocity is greatest at the beginning. Well, we just said the horizontal component is always the same, So no, not true. The acceleration is positive. Acceleration is never positive. It's either 0 or it's or negative, but it's never positive. So 3 is not right. That gets rid of that one, and so E has to be the right answer. But for number 4, the ball's speed increases. In the x direction, it's constant, but as it goes up, it actually slows down in the y direction. So 4 is not right either. The ball's speed does not increase as it travels upward. In fact, it decreases as it travels upward. All right. So if I wanted to correct these statements, I would say the velocity of the ball, the y velocity of the ball is 0. The horizontal component of the velocity is constant. The acceleration of the ball is negative. And I could say during the entire trajectory, so just get rid of that. And then the ball speed decreases as it travels upward. If I wanted to make those statements true, that's what I would do. All right, good questions here, y'all. You know how to do this one? So projectile launched horizontally, like that. Describe the x position versus time. So I'm thinking about the x motion. I know in the x motion, the x velocity is constant. So I'm looking now for a plot with constant slope. That gets rid of that one and that one. This one has a velocity equal to 0. So that means that it has to be the, where it has a constant, in this case, positive velocity. All right. What else, y'all? Yeah, Luke? Exam 3 does not come in. That would be the yellow questions here, right? Isn't it? Yeah, exam 3 is yellow. That is only chapter 5. No, it's okay. You want chapter 3 or what? I think this is that one. Okay, this one, number 8. You're not going to see this problem on the quiz. It was in the concept test, but we skipped over those last 2 questions, remember? It's interesting, though, so let's just look at it. So if you aim at the target, then what happens is that the target falls through a certain distance, and at the same time, after you shoot your gun, your weapon, that the bullet also falls. And so what you want to do is you want to aim directly at the target, and when you do that, if you're aiming it so that it's aiming straight at the target, as you shoot and the target falls, that the bullet also falls at the same rate. But not on the quiz, not on the quiz. We didn't do this question at the very end of the concept test. But it is interesting if you ever find yourself shooting at a falling target, that you aim at it so that you're aiming, you don't lead. Like, aiming for the ball. But if you're shooting speed, so that's different. Right? That's different. No, I don't think it applies here. Do you shoot speed? Yeah. I know that you when you shoot speed, but they have a trajectory, they have a constant velocity. You don't lead, you lead, I mean, you never shoot at speed, it's just falling straight down. Right? Yeah. Okay. Well, you lead the coyotes too, right? Yeah. Who goes up and shoots coyotes? You go up and shoot coyotes? Yeah. Okay. Yeah. Exam 2, questions 2 and 3. What all 20 what? 21. Is this 21? Yeah. Number 2 and 3? Okay. Okay, so this is, oh no, this is, we haven't done this one yet, or not one like this. So you're probably going to see one that's ground level coming back to ground level, and also one that's like this. I'm pretty sure I put both of those on there. I want to make sure that you can do both of those. So be prepared for a problem like we did earlier, where it starts like that, and then also one that's like this, where I shoot off at a horizontal. And the key here is that the initial velocity in the y direction is equal to 0. The reason for that is that the angle is equal to 0 degrees, and if you do 30 meters per second sine of 0, that's equal to 0. The sine of 0 degrees is equal to 0. So v naught y is equal to 0. V naught x is equal to 30 meters per second. I want to know the speed of the projectile at the bottom of the trajectory. In order to know that, I need to know the time right here. In order to find the time, I just imagine that an object is dropping in a vertical direction, and that time will also be the same as an object that is following a path out to the side. So I just imagine that vertical drop. That vertical drop here is 80 meters. And I say y is equal to v naught y times t plus 1/2 ay t squared. This term goes away because v naught y is equal to 0. Y is equal to negative 80. Remember why that is, that it starts at 0 up here and then it goes down. So negative 80 is equal to negative 5 t squared. And so t is equal to 4 seconds. I think we've done this one. Anyway, so t is equal to 4 seconds. Then, if I want to know the speed of the projectile at the bottom, recognize that that speed has two parts, vx and vy. I know vx, it's equal to 30 meters per second, because it doesn't change. It's always the same as what it starts at the beginning. And vy is equal to v naught y plus ayt. That's 0 minus 10 times 4 seconds, so that's negative 40. And we did do this one. So that means that my Vx is 30, my Vy is 40, my V is going to be the square root of 30 squared plus 40 squared, which is equal to 50. That's similar to what we did before, where we had to figure out the two velocity vectors here and here. We already knew Vx because it's the same as at the beginning, and then Vy you have to determine. And then that gives you the two components of that resultant vector. All right, and then number 3, how long is the projectile in the air? We've already answered that en route, so it's 4 seconds. Remember, for the horizontal, the way that you get the time in the air is you ask, how long does it take to just drop vertically? Yeah, sure. Other particular questions? Or particular? Yep. Fall 2019, number 2. Okay, so I want to know the x component of the velocity. Nothing really matters except for the initial velocity and the angle, because in projectile motion, Vx is equal to V naught x. So if I know V naught x, I know Vx. Doesn't change. So V naught x, I know, is V naught cosine theta. So that's all I need to do. V naught, which is 50, cosine of 30, is equal to 43. 43.3 meters per second. Okay. Okay. You said number 2 and what? Okay. William? Sure. They're good questions, y'all. All these are good ones. You might see tomorrow. Okay, you're definitely going to have one of these. Okay, on every exam, there's a vector sum. That is where I have one vector on off axis and one vector on axis. Definitely going to have one of these. So be prepared for that. Want to know the sum of these two vectors? First thing you want to do, I like to draw the picture first. You should have plenty of time, so I would go ahead and do that. 6 units at 60 degrees from the positive x-axis. That angle is about 60 degrees. And then 2 units along the negative y-axis. Oh, I should have drawn that first one bigger. 2 units, so it's about that big. That means that my resultant vector is going to be about like that. So look, I can get rid of some answers. I know that it's not that, or that, because it can't be bigger, or rather, just from looking at my picture, I know that it's not bigger than the longest vector. So I can get rid of that one right away. And now I'm picking between B and C. I want to know the magnitude of A plus B. Next step, calculate AX and BX, AY and BY. AX is 6 cosine 60. BX is 0. BY is negative 2. AY is 6 sine of 60. Notice what I did here is BY. I had to be really careful about this vector to make sure that I get the sign correct. So you have to look at the angle and see which quadrant that vector is in order to know are the x and y components positive or negative. That's where the picture becomes really useful. In fact, I drew the picture like that with the tip to tail, but you might also want to draw it like this with AX like this and AY like that, just so that you know, or B, the vector B like that, so that you know that it's along that negative y-axis, and you get those signs correct. Next, I add these together to get Rx and Ry. That's equal to 3.2. And then if I want to know the sum of those, I do the square root of 3 squared plus 3.2 squared. Get 4.4. Yeah, B is the right answer. Definitely going to have one of those. Okay. Why was Bx 0? Because this vector right here is along the y-axis, so there is no component. I mean, if you really want to be consistent, you could say that Bx is equal to 2 cosine of 270, or 2 cosine of negative 90. That's going to be also 0. Cosine of 270 is 0. Cosine of 90 is 0. Okay. Okay, what is A plus B? Are you going to have one of these? Will you? Yes, number 1, I think. I'm pretty sure. So I draw A and I draw B. A is already drawn. So I draw B like this. And then the resultant, begin at the beginning, end at the end. That's going to be B. Also be prepared. I think there are some questions where, like for example, if I was doing 2A plus B, in that case I would just draw A but draw it twice as long, and then I would draw the vector B. And so the sum of those two vectors would look like that. This would be 2A, B, that would be 2A plus B. Sorry, y'all. Okay? daughter says only old people have ringers on their phone. Is that true? Do you have your ringer on your phone? Because you have a watch, right? Your watch, your phone. You have a watch. You have a watch with either of you. You want to answer your phone? So my daughter's the only one in the school that has a watch, or the only one in her circle of friends. I watch. I watch. Apple watch. Right, right. What's up? Same test. How the marks differ into on this one right here? Yeah, good question. So if this was A minus B, then your Bx and your By components would just be switched. So this would be -0, but there's no -0, right? So that just stays the same. And then this would become +2. That would be the only change, is that instead of having -2, you would have +2. That's because when you take that, when you negate B, then this vector is now in that direction. You're right, yeah. So the components for B, their signs are flipped. The hard part on these is watching this information about the orientation of the vector. You need to know which quadrant it's in. That's very important that you know which quadrant. Sure. There's one on every test, so there's plenty to practice on. Oh, but not on that test, so you have to go back. Let's do the exam one. Okay, this is, what exam is this? Fall 20? Fall 20 exam. Oh, this was back during COVID. So I think this is an online exam. Is that COVID? Fall 20? No, we were back in class by fall 20. Yeah. All right, so calculate the sum of these two vectors. Again, I might draw a picture. So 30 degrees below the plus x-axis, 5 units, and then 8 units along the plus y-axis. So that's a little bit bigger. And then my resultant is going to look like that. So I know that I can get rid of really anything that's more than 8. I can get rid of that, that, and that. Y'all see how I did that? Like if I've drawn this even closely, right, I know that this vector is definitely shorter than this vector. As I sketched it out. If you're not sure about that, that's fine. You just follow the technique. So first, AX, BX, AY, BY. AX is 5 cosine 30. BX is 0. I made a mistake. What's my mistake? You'll see it? See it. AX should be negative, right? AX should be -5 cosine 30, right? This is A right here, so it has a Y. Excuse me, no, I'm sorry. I misled you. AY should be negative, yeah. That should be positive. Yeah, so this should be -5 sine of 30. It's 2.5. And then BY is equal to +8. Right, and this is 5 cosine 30. That's 4.3. Then you add them up. AX plus BX is 4.3. That's RX. AY plus BY, that's RY, is 8 minus 2.5. That's -2.5. That's what? 5.5. And then I do the square root of sum of the square root of squares. 6.987 units, 7 units long. Draw the picture. That'll help you to sort of whittle it down a little bit to the right answer. And then take the x and y components, add the x components, add the y components, use the diagram here to find the result. Or use your inverse case to find the table. That's what I'm asking. You might have to know that too. Okay, on? Other questions, particular questions? Or just general, hey, yeah. Number 3. Okay. So we worked one similar to this, but I don't think we did this part of it before. But you definitely will have a horizontal launch. So I have an object that is fired horizontally. Remember, V naught x is equal to V naught, so that's going to be V naught x is equal to 10 meters per second, and V naught y is going to equal to 0. Those are our initial conditions. Those are important. To find the time, I take the fact that I know the vertical height, and I say y is equal to V naught y times t plus 1/2 ay t squared. But since V naught y is 0, that whole term goes away. So I can find the time that it takes to go through that. And remember, this is like finding the time to drop vertically. That's the same amount of time. So I have minus 80 equals negative 5 t squared. T is equal to 4 seconds. Gosh, I like these numbers, apparently. And now if it's in the air for 4 seconds, I can find the x range, which is Vx times t. That's 10 meters per second. That's not the acceleration. That was the original speed times 4 seconds. That's 40 meters. So D is the right answer. Okay. All right. What else? How y'all feeling about this quiz? Feeling okay about it? They're not non-committal, most of you. Probably best to get some sleep tonight. I know that's probably not what you think, but that probably is best. And just to relax. Big deep breaths tomorrow. Other questions? All right, I'm going to stop this.